Welcome to the last part of recursion. We will continue writing some examples on how to apply recursive methods in solving problems. To start writing our examples for recursive methods, we will take Fibonacci sequence as a sample problem. We will study how the sequence of numbers are generated and how these numbers are computed. Fibonacci sequence is a series of numbers from 0 to infinity. To give you an example of what a Fibonacci sequence is, let's take this example. The next number is usually computed by adding up the two numbers before it. We got 1 because we added 0 and 1. We got 2 because we added the two numbers before it. We got 3 because we added the two numbers before it, the 2 and 1. We got 5 because we added the two numbers before it, the 3 and 2. We got 8 because we added the two numbers before it, the 5 and 3. And we got 13 because we added 5 and 8. And we got 21 because we added 13 and 8. And we got 34 because we added the 13 and 21. So this continues to infinity. You get the next succeeding number by adding the previous two numbers. So what we will do now is to write an algorithm that will compute the Fibonacci sequence for a given range of numbers. Okay, to start writing our Fibonacci sequence, we will make use of a method. And then later we will turn this method to become a recursive method. Okay, so to begin with our method, at the bottom of our main method, we will write here static, let's say int, followed by the name of our method, which in this case is Fibonacci. And then we will assign a parameter variable, let's say num. And then we will determine if the number is less than 2. If it is less than 2, then we will write here, we return that number. But if not, then we will continue to process and compute for our Fibonacci sequence. So we will write here an array of n with a default size of whatever the value of our num. And then after that, we will initialize a value of 0 and 1 as our first two-digit number for our Fibonacci. And to do that, we will state here for n0, we'll write the 0, and for n1, we will write 1. So these are the initial input that will serve as basis for the succeeding Fibonacci sequence. And then we will make a loop statement just below of this assignment statement that we have written. So for I, we will start computing our Fibonacci sequence at 2, while I is less than or equal to num, then I plus plus. Okay. Then from here, we will make use of I to refer to the index of our n, and then we will state here that this n, we will get the value of our number subtracted by 1 together with the second previous number, and to do that, we subtract here by 2. So there you go. This is I minus 2. Then last, we will now return the value of our n. So n return, we will just return the n of the num. So let's review what we have written here. So what we did is we created a static method that returns a value, and that method is the Fibonacci. It has a single parameter variable with a data type integer, and that integer is num. And then on this line, we wrote here that if num is less than 2, then we will stop computing the Fibonacci sequence because we will not be able to compute if the input is less than 2 because there is no reference for us to get the succeeding number if we have less than 2. And then the next line is we created an array here, and that array is an n, and then we initialize the n with a size of num plus 1. So whatever the value that we have passed in our num variable, it will be added by 1, and that will be the size of our n. And then we initialize as the first two indices of our n. So the first index we assign 0, and the second index we assign 1. Because with this, we will be able to get the succeeding number for our Fibonacci sequence. And then after that, we made a for statement here that starts at 0, and then it will continue on computing our Fibonacci sequence while I is less than or equal to num. So what we are doing here inside of this for is that we are getting the previous numbers of our n, adding those previous numbers, and then from there we store that result to the index of n of whatever the value of I is. After computing all the value for each element, then that's the time that we return the computed value, the n with the index of whatever the value of the num. Okay, so let's call this method inside of our main method. So let's write first here the console.readline, and then we will state here write line, then Fibonacci, and then let's write here, let's say 10, and then let's try running this application. Okay, so we have an error here. So because what we did here is we initialized already our first element with 0. So that is why we should not touch that element. Instead of starting from 0 here, since 0 is already here, 0 and 1, so we should start at 2. So again, let's give this a try. So there you go. This shows that the 10th sequence of Fibonacci is 55. Okay, let's have another example. Let's try 8. So the Fibonacci sequence there is 21. So let's examine if we were really able to get the correct answer by using a notepad. If the given sequence is 8, then meaning we start at 0. So this is 1, 2, 3, 4, 5, 6, 7, 8. All right, so this is now the 8th sequence. So we were able to get the correct answer. So let's try 7. So it should fall on number 13. So let's give this a try. Let's try 7. So there you go. So 7. So we were able to get the correct answer. Okay, so that's how you write a method of Fibonacci sequence. Now the next move is to turn this method into a recursive method. Okay, so how to do that? So let's just copy and paste this at the bottom of our Fibonacci method, and then we will name this Fibonacci recursive. So when do we stop? That is the first thing that we have to identify. When should we stop? We will stop if the num is 0 or the num, remember that 0 is less than 2 and 1 is less than 2. So whenever that is the case, what we will do is just to return the num. So this is where it will stop. But if this is false, then we will do the recursion. We will write here return Fibonacci recursive the num minus 1 plus the Fibonacci recursive the num minus 2. So that's how simple it is. We only have 3 lines compared to the first method that we have. We have so many lines here. So but In order for us to test whether this is working, we have to call this inside of our main method. So on our main method, let's comment this out. Let's copy this and then paste this just below our commented line. And then we will rename this to recursive. Then let's write there 7. So let's see if we can get the same result. It should give us a result of 13. Okay, so we are referring to this Fibonacci recursive. So let's give this a try. There you go, 13. So let's say 8. There you have it. It gives us 21. So that's how we do the recursive method. What we did is we wrote the algorithm to compute the Fibonacci sequence using a static method. And then after that, converting that static method into a Fibonacci recursive method. So this is now the recursive method of our Fibonacci sequence. So that's all for this video, and then see you in the next lectures.